Assalamualaikum everyone. This is an empty glass and I have a bottle. Let's see if I pour the water into it. Okay, the water level goes up and up slowly. Alright, you see the water level is very near to the top of the glass. Actually, it's approaching the top of the glass. Alright, so this is called approaching. In mathematics, limit has the same meaning. So my name is Muhammad Tayyib. I will teach you derivatives and the geometric concept of limit. When we take the nearest value of the two from the left side and from the right side, value is very near to the 4. See, this is 4. So it's very near to the 4. So this is called limit. So now let me understand the concept of average rate of change and instantaneous rate of change. Alright. So let us consider you are going from Jeddah to Riyadh. Let us consider, and it's a distance almost like 900 kilometers. Okay, so you drive from the Jeddah, okay, and you go to the Riyadh. So this is Jeddah, this is Riyadh. What will be the speed, average speed, when you go from Jeddah to Riyadh? Okay, so we have let us consider we have 90 kilometer average speed. Okay, so we can say that this is average rate of change. What about if somebody asks me what is the speed at this point? Okay, and what will be the speed at this point? So that means these are the specific points. They are asking about the specific point speeds. So we need to tell them the speed. Let us consider the speed here is 120 km per hour and the speed here is 70 km per hour. Definitely you can't go with 90 km so on. Okay, so that means this is called the instantaneous rate of change. So these are the difference between the average rate of change and instantaneous rate of change. So let me understand from the diagram, from the figure now. Alright, so consider we have a Cartesian plane here, x, y, and say we have a function y equal to f of x. Okay, this is our function. We have to draw here. Function is what? We don't know. I'll take the general function. So there must be a graph here. So I take the graph like this. Okay, so this is the graph of y equal to f of x. Alright, so definitely there are some value of x. On x-axis we have the values of x and on y-axis we have the values of y. Let us consider this is a point. If this is a point, definitely we have a value of x and the value of y. So I take the value of x as x. And what about if I take from here? So this is x. If we take the value from the right side of x, that means we have to add this. So definitely we have x plus something. So I take h here. Okay. So x plus h. So this is x plus h. Definitely we have the values of y here as well. Consider this is f of x because y equal to f of x. Alright. If this is x plus h, it will be f of x plus h. Alright. So what happened if I join these points? Okay, it should be a straight line. What's happened? You see, this line is called a secant line. And so we have y2. Let us consider this is y2 and f of x plus h minus f of x over and x plus h minus x plus h minus x. These x cancel out and we have the values of f of x plus h minus f of x over h. Alright, so this is a slope of average rate of change, which is also called the secant line slope. Now we need to find out the slope of instantaneous rate of change, which is also called tangent line. What about if I take the same graph and definitely we have to draw the tangent, but how? Just understand. This is the line of secant. And what about if h is very small, so that we take 0? What's happened if we take h equals to 0? This value will come from right to the left here. You see? So if I take h equals to 0, that means this line will merge with this. So that means there will be no line here. Okay? So that means this graph and this point will move from like here, and then this point will here. Slowly at one time, this graph will be like it touches the one point of the graph. Okay, so we have 2 points in the secant line, and we have only 1 point in the tangent line. So this is called instantaneous rate of change, which is also called tangent line. The difference is the limit. There is no limit here, and there is a limit h approaches to 0. Okay, so this is how we convert the secant line into a tangent line. Okay, so now we talk about the derivative. Actually, we already did this. What's this? This is the slope of instantaneous rate of change. This is also called the slope of tangent, and this is actually called the derivative. Let f of x equal x squared. Consider the function is x squared. Okay, so how we can find out? By using this formula. This is called the derivative by first principle. Put or replace x with x plus h. So we have f of x plus h equal x plus h squared. We need to find out f dash of x. Okay, and the formula is here. We need to just put the values here. So slope m equal f dash of x equal limit h approaches to 0 x plus h square minus x square over h. So just open this formula by using the identity a plus b whole square. So a square plus b square plus 2ab minus x square over h. What's happened here? X square cancel out, and what's happened here? We have limit h approaches to 0. H is common from these two, and we have h plus 2x over h. H is cancelled out. Now it's time to put h. As h approaches to 0, we need to just put the 0 here. So when we put 0 here, it will become 2x. So derivative is f dash of x is 2x. So I need to ask you a question here, conceptual question. What's this? You notice? What about if I put h equals to 0 here? If I put h equals to 0 here, the denominator will be 0. And if the denominator is 0, that means it will be undefined. Okay? So be very careful in this type of questions. You have to be very careful that you need to solve the question, whole question first, and then put the limit. Okay? So this is how we can solve by using the first principle. Alright, so this is our class. We covered different topics here. The first one is we define the derivatives, we define the limit, and we take examples. And lastly, we convert the average rate of change to instantaneous rate of change. That means secant line to tangent line. And we see that the tangent line is actually a derivative. Okay? So thank you so much for your attention. If you have any question, do ask me. Alright? So thank you so much. Allah Hafiz.